Good afternoon, everyone, and welcome to another virtual tour of outer space. My name is Josh. I have the privilege of being your presenter today as we take a tour around our part of the universe. If you could use a distraction from headlines and all the stuff going on in our lives, tune in for half an hour. We are going to go wherever you think sounds cool and tell you some of the interesting stuff that's happening around us in space. So I'm here. Normally I'd be broadcasting this show from my home, but this is my home away from home, the Morrison Planetarium. I spend a lot of time here, but I don't actually live here. They don't let me. I am currently inside the bowels of our planetarium, way below where people sit, but almost directly underneath. And I'm using our planetarium software called OpenSpace. OpenSpace is really cool, something that I would recommend you checking out if you haven't already, and something you can actually download and use at home. Instead of costing thousands and thousands of dollars like other packages of software, this is something that's totally free. It's being developed by NASA, the American Museum of Natural History, and you can actually see it right there next to me. So if you want to check it out and basically do the exact same show I'm doing, check out the OpenSpaceProject.com, download it, and fly yourself around. Entertain your family. Memorize as many facts as you can and zoom around, and you're basically a planetarium presenter already. So right now we are looking out at a star field, 3 very bright stars that are wrapped around our Milky Way galaxy. I hope you folks can see that right there in the middle of our screen. You can see 1, 2, 3 very bright stars. This is the summer triangle. Why the heck am I showing you the summer triangle in the middle of winter? Well, this is the asterism I happened to settle on. We are looking out into space from planet Earth. So as I crane our view around, I can give us a nice quick rotation. You can see we are right above San Francisco in effect, but we can't see San Francisco. And that's because we are officially on the nighttime side of Earth, but just barely. That's why we can still see some of our summer stars. Now, this glowing line you can see right here is a wonderful representation of Earth's atmosphere. On the museum floor, we've been talking about color and light a little bit in our Color of Life exhibit. And I thought this would be a cool thing to show you. Check out all the blue you see there, scattering light. That's why we get a nice blue sky when we look up from underneath the atmosphere. Our air is very good at scattering blue light. But if you look over here, notice that red on the very bottom. Where have you seen a red sky right when the sun goes down? So that red light is traveling through Earth's atmosphere, hitting our eyeballs and giving us the view of that beautiful reddish sunset. It's been pretty clear in San Francisco, so I'm willing to bet we would get something like a beautiful sunset today, although clouds really can add something, and I haven't seen too many clouds in our sky. Okay, looking down on planet Earth, we actually can see the clouds that we would be seeing as of yesterday. When you look down on planet Earth in open space, you get a wonderfully up-to-date photo. Now, if you are like me and you've spent a fair amount of time playing around in software like this, you may have tried out Google Earth, you may have tried out Bing Maps. The Microsoft product has some really good mapping. This is different, because when you look at your house in Google Earth, you might see where your neighbor's car was parked months ago, but not where it was parked yesterday. It's because the photos don't update that often. This photo of Earth is brand new every single day. So we get to see where the clouds were as of yesterday around noon. You can tell when the noon part of the photo was taken because of this very reflective band across the surface where the spacecraft was passing overhead, right as the sun was passing overhead as well. Looks like we've got a great vote for another planet, another blue planet even. Let's go check out Neptune. Now, before we do, I'm going to give us a little bit of context. When we look down at Earth, think about the colors you see. Yes, Earth is predominantly blue here, but we can also see some white from our clouds. And check out Australia. Australia is famous for its red dirt, and you can see a lot of it from up here. There's also browns and greens across Australia. Our planet is not monocolored. But let's check out Neptune for that sense of comparison. Neptune, as I said, is also a blue planet, but not the same kind of blue. It's going to take us a while to fly out to Neptune. It is the farthest of the major planets. When we get there, very different than Earth. You can still see some white spots. Those are whitish clouds. There are dark spots too. We actually have a depressional storm on the surface of Neptune. That's really cool. An area that's a little lower than the spots around it. Now, looking around Neptune, that beautiful deep blue color might resemble some of the deepest, darkest parts of Earth's ocean, but this light clouds and dark clouds are totally different. We pretty much only have light clouds here on planet Earth. So Tricia, thank you for the recommendation. Neptune is a great color contrast to our own planet Earth. But let's try something else out. When we think about Neptune, some people like to call it a gas giant. My preferred name is ice giant because I think it's different enough from Jupiter and Saturn that it deserves a different classification, and it's very cold in this outer part of our solar system, so things that are liquids or gases closer in are solids out here. So an ice giant sounds like a pretty good name. But as we look at the edge of Neptune, you don't notice as much of that atmospheric limning, that change in coloration as we saw on Earth's atmosphere. Yes, Neptune does have a gas envelope wrapped around it, but that actually comprises a lot of its outer structure. Underneath that, we probably have solid, slushy material, sort of like the drinks you get at convenience stores. A lot of ice and syrup mixed together. The thick fluid mixed with an icy matrix sounds a lot like the outer layers of Neptune. Now, what is that ice made of? I think Daniel has a great question. Where do we find water on other planets? There probably is water on Neptune. Seems appropriate since Neptune was an ocean god in Roman mythology. But would it be drinkable? Probably not. Just because of the other ingredients mixed in there, it would be a very different compound than what we would call water. Now, we can also talk about the phase of it. Out here, water would probably be frozen, so it'd be more ice than water. So there are other ices to be sure on Neptune, but some small part of them are likely going to be water ice. Now, if we wanted to see a lot of water, we can look at Earth. Earth is famous for being a water planet. I would actually say that's a more accurate name than blue planet. Most of our surface is watery. Not all of our watery surface is blue. But if you want to see an icy planet, let's see if I can't throw something at you that's a little bit out of left field. Because we did discover ice in our solar system in a place that was not expected. That is, of course, Mercury. Now, where are we going to find ice on Mercury? At the poles. Turns out the poles of Mercury are a great place to hold on to ice because sunlight does not really strike them. In these permanently shadowed regions, or PSRs, which are different than PSLs, we can actually see, or can't see, areas, and that's because sunlight never falls into them. The bottoms of deep craters, for example, sunlight might strike the edges, but never goes farther inside, so we are pretty reasonably certain there is water ice on those poles of Mercury. But when we're talking about water, generally we're not content with ice. We want liquid water. Well, for sure we have Earth, but again, let's try other places. We think there might be a small potential for liquid water on Mars. So let's head out there. Mars is a beautiful planet to check out, and if you are an enthusiast about Mars and its potential for habitability, what human beings might be doing on the surface of Mars in the next 20, 40, 60, 80 years, I cannot recommend highly enough. Tune in this Friday. We are going to be talking to J.R. Skoke, who is a fantastic Mars mission specialist, knows a ton about it, and is gung-ho on developing technologies that might allow human beings to exist on Mars. So looking around here, you can see a bunch of Mars's big features. Now, they look to me like canyons and rivers we have here on Earth, which are largely carved across the surface of rock by moving water. That's not the case here necessarily. The biggest features on Mars are probably volcanic or tectonic, but I noticed something while we were flying around with JR. If you spend enough time looking at the surface of Mars, you will spot something that for sure looks just like a river feature here on Earth. You just can't spend much time on Mars before you discover something that looks water feature-like. Mars has plenty of evidence of ancient water flowing across its surface long, long ago. Okay, so that's again the spot where we might find liquid water. There's another moon called Europa that might have ice and liquid, but I just saw a recommendation from Katya to go visit Io. Now, Io is next door to the moon Europa, so we might stop by Europa, but I'm content to go visit Io because Io is amazing. Mars has the biggest volcanoes in our solar system that human beings have ever seen, you could even say. So you could say largest known volcanoes in the universe, but that's a kind of sneaky way to say that sentence. If we're talking about active volcanoes, though, we don't generally look at Mars. All of Mars's volcanoes are extinct. They're dead. They're not going off anymore. That is not the case here on Io. We see tons and tons of geological activity, volcanic activity, constantly changing the surface. Now, look around here for a minute. You see any craters? I can see lots of calderas, like the bowl-shaped impressions that make the mouth of a volcano. I can see a lot of features that maybe look a little bit like a crater but fall apart under closer examination. Turns out there just aren't that many big craters on Io. Ever wonder why? Well, imagine if I dropped a rock onto the surface of Io and it smashed a big hole, made a big crater on the surface. How long would it stay there? Until the next volcano went off and then covered it up with lava. So probably not that long on a surface like this that's rapidly changing. So because of that, we say that the surface is volcanically young. Not a whole lot of visible changes, aging, weathering, because of this constant volcanic activity. The source of the activity is Jupiter itself. It gives Io and the other Galilean moons something of a gravitational massage, squishing their outsides, adding energy to the system, and keeping them nice and toasty warm on their insides. Okay, we had a question asking about Ryugu. I will tell you what, Christine, I don't have Ryugu in this profile. Turns out when this profile was made, all those moons ago, we did no up-close photos of Ryugu. Now, since then, we've added it to it, and it even exists in 3D models. I don't know if it's in the most recent version of OpenSpace. Someone on the OpenSpace channel for sure would, but I can tell you that a ton of asteroid objects have been added to new OpenSpace, so I wouldn't be at all surprised if it was in there. So a reason for you to download it, check it out, play with it, enjoy it. It is a wonderful program for sure. And if you want to see Ryugu up close, check out our cosmic conversation from last week. Can we see Enceladus and talk about the possibility of life there, please? Oh, you're breaking my heart. Now, I love talking about the possibility of life inside ice moons, but recently I have been on a big kick for Europa and not so much Enceladus. But that's unfair. Enceladus is a wonderful, beautiful, amazing object with a ton of interesting stuff going on. That's no one's fault. Enceladus is a great place to visit. I just really like Europa. Okay, here we go. Now, it always looks to me like Enceladus is one of those assets that's not quite working quite right, that we just get a smooth gray ball. Happens from time to time, mostly when my computer can't handle what I'm throwing at it, but it's actually just a really smooth whitish surface. If you check out Europa, or our cosmic conversation about Europa a couple weeks ago, we can see a wonderful diversity of features on the surface of Europa. That's not Enceladus. Enceladus is a different world. It's a much smaller moon. So I don't know necessarily how much of it will translate in terms of the types of structures we see, but nonetheless, I'm going to give it my best shot based on what I learned about Europa to give you some interpretation about what's going on Enceladus. So let's check this out. You can see a whole bunch of wavy features. There's these gigantic, powerful cracks moving across the surface, as well as ice that seems to be forming inside them. What we see here is the icy shell wrapped around the warm, nougaty center of Enceladine oceans. We think there's probably more ocean around the South Pole. That seems to be where stuff is concentrated for new activity. These are called the tiger stripes, and they're actually a spot where we have seen geysers shooting that warm, salty, liquid ocean out into space. Warm, salty ocean seems to be the place to look for life here on Earth. We think that's where life started in our oceans. So finding a ocean that's liquid, that has a mix of elements and stays fluid, could be a perfect spot for life to exist out here. So to me, the real argument stops being, is there going to be life on Enceladus? True, it's an unanswered question, but I think it's going to be, are we talking more like jellyfish, sea monkeys, whales? What kind of critter are we looking for? We've not found life anywhere else in the universe, but Enceladus and Europa to me pose the most awesome possibilities within our own solar system. Mars may teach us about life long ago, but those two might still have life. Ganymede, thank you, Karen. And of course, Jeremiah, I love visiting Galilean moons. We already got one, but what a wonderful excuse to go visit another. Let's go check out Ganymede. Now, remember when I showed you Io, the surface was smooth, very few craters. As we zoom back to visit Ganymede, I want you to start checking out the surface. Now, Ganymede is a special moon, to be sure. Aside from being a Galilean moon, aside from having this ancient, cratered, icy surface, Ganymede is actually the biggest moon in our solar system. It's much larger than the planet Mercury. Now, looking around on here, you can see some big, dark, blocky structures, some lighter stuff smoothed around. You can see where this seems to have broken in the past. The material from the lighter stuff moved through it. There's a ton of amazing history to be seen on the surface of Ganymede because we don't think it changes very much. It's possible there is activity underneath the surface, maybe some warm liquid moving around. The other Galilean moons seem to have some aspect of that. Why not Ganymede? But the crust is also likely very thick. So even though there might be stuff moving around way down there, it's not moving very much. It's not moving all the way up to the surface, and it's for sure not repaving big areas. But some of that repaving obviously happened in the past. If you look around long enough, you'll see that there's a very bumpy spot right next to a very smooth spot. And that means they probably didn't form like that. One of them got hit by stuff over time. Maybe area around it was subducted or moved back into the middle of Ganymede. It was melted down and new stuff came up. So a great question from Daniel. Do other planets have tectonic plates? Earth is the only planet in our solar system with active tectonics. That's true. But it's not the only object in our solar system with active tectonics. You can see something maybe like tectonic activity on Ganymede once in its ancient past that might cause some of those interesting structures. But what I can tell you 100% is that it is not the only object with tectonics because, ignore Jupiter, I was trying to fool you, Jupiter does not have tectonics. We have Europa. I finally got us here. And on Europa, we can see definite tectonic features. It's not a planet. It doesn't have real tectonic plates, but stuff moves around, jostles around, bumps into each other, grinds itself against one another, subducts, melts, and comes up as volcanoes. We see a ton of similar structures between the rocky outer crust of Earth and our liquid rock mantle. This has a rocky outer crust of ice and a liquid water mantle moving around, but they seem to act upon each other in a very similar way. So by studying Earth's geological formation processes, we can make better and better guesses about Europa's geological processes. You can see some of these beautiful wavy lines. So cool. Okay. Stephen asks, are there any stories and images of the Shoemaker-Levy collision with Jupiter so many years ago? I'm glad you're enjoying. Shoemaker-Levy is actually one of the earlier astronomical phenomena I think I recall. I remember seeing photos of it and people talking about how amazing it was, but I just really wanted to see Jupiter like get hit by something giant, and it was lame that it broke up into little pieces. But we didn't really have a great understanding of how comets hit before that, so it was a great object to study. I can't show you those pictures. I don't have them loaded up in the software. That's the downside of having a kind of total request solar system sort of show, but you can definitely find them online. The best ones I've seen aren't great photos necessarily, but are hugely scientifically illustrative, that we are seeing this object break up and slam into the surface of Jupiter. And there are some Hubble photos, I believe, of the infrared effects, where you can see something smashed into the cool outer surface, revealing the warmer parts of Jupiter below. So this was a big wake-up call. Like, we should be able to spot comets like this, figure out where they're going, and if they are ever going to get close to planet Earth, come up with ideas about how to divert, deflect, protect ourselves from them. Jupiter exerts a huge amount of gravitational influence on our solar system as a whole. You can very easily say Jupiter is the second most gravitationally powerful object in our solar system, second only to the sun. However, that's kind of misrepresentative because Jupiter has a tiny fraction of the influence as our sun. It just has way more influence than all the other planets, I think even all the other planets put together. So when we're looking at Jupiter, this is poetically and in kind of a way that some astronomers shy away from anthropomorphizing, making them sound like humans. I like to think of Jupiter as sort of the big brother of the solar system. It will protect us from comets and asteroids by deflecting them, diverting them, or absorbing them. But sometimes it'll also disturb a rock and send it hurtling into the inner solar system, which is where we think there might be a potential for dangerous stuff coming to hit planet Earth. You are so welcome, Stephen. Thank you for asking questions. Trisha asked, what about the Great Red Spot on Jupiter? We actually got a great view of it. It happens to be sunward at the moment, so it's facing towards the sun. That gives us a beautiful view of our Great Red Spot that we say comfortably is contracting. Now, contracting for some people means shrinking, but that's not necessarily a direct scientific correlation. When it's contracting, it seems to be getting taller, but it is also getting narrower. When I was in school, in elementary school, I think high school too, we learned that the Great Red Spot was 3 Earths wide, that you could fit 1 Earth here, 1 Earth here, and 1 Earth here. No problem. Now, in college, we pointed telescopes at it. We calculated using the telescope how much it was magnifying, how big it appeared in our eyepiece compared to the diameter of the optical part of the eyepiece. And we discovered that it was smaller than any of us expected. It was, in fact, only 2 Earths wide. That was a big change. And then this last year, we discovered that it's only about an Earth and a half wide. Earth isn't growing. That's not what's happening here. So the evidence would be that Jupiter's spot is shrinking. Now, it is getting taller, so it's changing. Would be the most scientifically valid way of describing it in a single word. The Great Red Spot is changing. Does it do this often? Does it do it only once every few thousand years? We don't know. We haven't been studying Jupiter that long. Our first observations of Jupiter and its Great Red Spot date back a couple hundred years. So for really good observations of the Great Red Spot and how it changes, we don't have a very long time frame. Okay. Shyama asked, can we get close to the sun? Can we see it? You can see the sun by going outside. Don't look straight at it. You can feel the sun's warmth on your face from here on planet Earth. That's 93 million miles from the surface of the sun. And from the orbit of Jupiter, we are many times that. I think it's about 12 times 8 minutes. It's a long while. But using the Magical Planetarium software, we can get closer to the sun and closer and closer and closer and closer and closer until we get closer than any person would really want to go. Because, well, your spaceship and you would start turning into a different phase of matter. Maybe burning up, maybe melting, just not a good time. So visiting the sun is something that our planetarium software allows us to do. I will say right now the sun is more exciting than it has been in weeks. And why is that? It's got a teeny tiny cluster of sunspots. You can't see it on here because this is a static image of the sun, but once upon a time, a long time ago, we had a very active sun. We saw sunspots every few days, weeks, months. Now we see a little tiny cluster of sunspots, and all of a sudden, all of the astronomy communities online go bananas, which is really sad. They're getting excited over nothing, but maybe we all just need something to be excited about at this point. But it tells us how rare sunspots have become. So if you have a way of viewing a sunspot safely, now would be a cool time to do it. If you want to discover a way, check out a pinhole projector. You can actually see a little bit of sunspots with those. It's a fun craft activity, and you can make one, test it out, make sure it's safe from the comfort of your own home. All you need is a cereal box, some scissors, and some paper. Okay, we had another request come in. Could the gas atmosphere on giant planets be ignited or used as a future energy source? It is hydrogen. Hydrogen does burn, if I recall. But I will caution any future prospectors from heading out to Jupiter or Saturn to collect up a whole bunch of hydrogen to bring it back to Earth. You're not going to make money. You're not even going to break even. Yes, that is combustible. Yes, it's potentially a fuel resource, but only if you were already going there. Now, collecting up stuff to collect hydrogen on the surface of Jupiter is going to be a big and expensive project. Launching it off of Earth, even more expensive. There was a group of people, I feel like in the 70s, that came up with the idea that if we launched enough nukes at Jupiter or Saturn, that we could get it to, pardon me, that's our compressor. Got to keep the planetarium safe from fire. If we launched enough nukes into the surface of Jupiter, we could get it to ignite, and then we'd have 2 suns in our solar system, and it would do something, and maybe aliens were going to do it. There's a lot of discussion. I think that if you launched all of Earth's nukes at Jupiter, not much would happen. Jupiter's a very big planet. Nukes might irradiate or make active a small region. If Jupiter were going to ignite from something like that, it probably would have done so the very first time a comet hit it or an asteroid. They impart a huge amount of damage and energy. But it hasn't. Jupiter seems to be as inert as it ever was. When we talk about these gases, yes, hydrogen is combustible under specific pressures, under specific temperatures, under the right conditions. I don't think Jupiter is the right condition. So even though it is made of something that stores chemical energy, it's not like it's going to be easily liberated. If it was, Jupiter probably would have exploded a long time ago. We had another question pop up, I think from Jeremiah, wants to see Mars's biggest moon. Okay, so Mars has 2 moons to choose from. It has Phobos and it has Deimos. Deimos, we don't have a model of, I don't think, because it is so inky-dinky, so tiny, but we can see Phobos. And Phobos is Mars's greatest moon. Okay, so heading out to Phobos. If you want to impress your friends, here's a cool trick. A lot of people say Phobos and Deimos because that's kind of how the words look. I've heard from people who speak better Greek than I do. Phobos is the preferred pronunciation, and Deimos. So Phobos and Deimos are the 2 moons of Saturn. My accent is wrong, I'm sure, but that's a little closer to the pronunciation. Here we go. When you look at Phobos, I love calling it a space potato because, let's face it, it looks like a space potato, covered with these long lineae, long lines and cracks. We actually, I think Mary, who's producing for me, wrote an article a while ago about how there's some idea that Phobos might have been a ring at one point, collected together into a puffy, porous, almost pumice-like rock. That's an alliterative sentence. And then maybe ground down again, turning into a debris ring, and then turning back into a moon. The reason people suspect this of Phobos is because it's very low density. It's not a very solid, substantive rock. It seems like it might be a light dust pile or a pumice pile. It doesn't have as much mass as it does volume. So that leads to a very low density. So in looking at Phobos, we can kind of see its low mass because it's kind of a lumpy, bumpy shaped object. Big moons like Ganymede would make themselves round. But here is my favorite Phobos fact. Again, that's alliterative. I'm good at that today. Imagine standing on Phobos with a baseball. If you were on the Mars side of Phobos and you wanted to throw that baseball just as hard as you could, you might be able to, if you have a good arm, have that baseball leave the surface of Phobos, fly through space, and bonk down onto Mars. You'd have to have a pretty good arm. I don't think I could do it, but I bet there's a lot of people in the Major League Baseball group who would have no issue with it. But being able to hit a planet with a baseball from the moon, that's something really unique and really special. But with that, it is 4:58 by my clock. We are running low on time. I'm going to start heading us back towards planet Earth, see if there's one last question or two we might be able to answer along the way. But in the meantime, I would like to thank all of you for joining us here for our virtual tour of outer space. Sometimes the universe can feel a little conflicted, a little close in, a little difficult. And for me, there is no better cure than letting your eyes and brain wander out amongst the stars and planets of our own solar system. So if you're feeling a little claustrophobic, a little stuck at home, maybe a little over things on this planet, take a break. Go visit some other spots. Marvel at how beautiful and wonderful our solar system and universe are, and it makes Earth feel a little bit more welcoming as soon as you return. So with that, thank you all for tuning into our weekly broadcast. We hope to see you next week. We are beginning some of the considerations around what a completely reopened academy might look like, and that's a really exciting thing. No official dates yet, but as soon as we are able to find a way to open safely, we are going to get more things here open to you. I'm excited to see more of you coming to visit us at the museum. It is always a joy. But thank you all for joining us. Stay home, stay healthy, and we'll see you next week.